going back to the cheat method for finding a recursion. So one thing I mentioned before is that I might actually want to use a recursion to calculate something if I already have to calculate all the values. So if I already have to calculate all the values, I could put them in a table and then use the recursion to do a nice table lookup and have less complicated math to do. So if I had to do all the values of that summation we were looking at, I might as well save them in a table and add those. And let's see. What if I have f of n equals a to the n, and I've asked for a recursion for that? So the cheat method is to write over this formula again, but put n minus 1 in there. Subtract the left-hand sides. Subtract the right-hand sides. And then solve for f of n on the left. By the way, all of that's in the exponent. And I need also a what? A basis. So if I ask you to give me a recurrence and I've given you a function, you can do just exactly that. And did you notice that I actually haven't tried to make this simpler at all? Because I didn't ask you for the simplest, most coolest looking one. I just asked you to write a recursion. And a recursion has f on one side and f on the other side where the number is smaller, and it has a basis. So that's all you have to do. So the cheat, I call that the cheat method because you could use Robot Brain for that. I should call it Robot Brain method. So that's nice because now if I need a recursion, I can make one easily. Can you make this look nicer? How do you do it? Factoring is your friend. So if I had to make that look nicer, so usually if I have to write a recurrence for something, it's because actually what I'm trying to do is do less complicated math. Because I have to calculate all the values, so I could use a previous value to do simpler math. When might you want to do that? When you have unimaginable systems to you that actually, you want to minimize the computation time. Can you think of any systems where I might want to minimize the computation time? All of them? Okay, that's not a very restrictive answer. What kind of systems do I want to minimize the computation time? How many of you play video games? Okay. How many of you play video games that are 3D? Okay. If you play 3D video games, they are doing a heck of a lot of stuff while you're in there. How many of you play video games that have a whole bunch of characters in them? Okay, so every one of those characters has a whole bunch of calculations going on to figure out what they're going to do next. If I have to do a whole bunch of calculations for like 100,000 characters in my game, I better do them as fast as possible. And if I can, I'd like to have them in a table so I can look them up. And the table better fit in my memory too. And if I'm on a console, it used to be consoles were like really limited. Now you can really think of like a PSP or something. You're going to have limited memory. So when you're building a game system, you really have to balance your computation and your memory usage to optimize it, because basically everything that gets done in your game has to be done between the frames that you're looking at. How many frames per second are in a game? Okay, variable is a general answer again. What is the minimal number that you have to have? 30. Why is it 30? Because if it's not 30, you can detect that they're frames. So it's usually 30 to 60, and they don't usually bother with more than that because that's extra work we don't need to do. So your human brain, if you have 30 frames a second, it's like those flip books with cartoons. Your human brain will integrate them and assume that there's actually people moving and stuff. So games have to balance like how many of those are going to put on the screen, and in between doing those, they've got to do any calculations to figure out all the math that's going on in the world. So you might actually want to have some additions to do instead of some multiplications, because they actually technically do take a lot less time. Okay, so I might want to make this so it's actually I don't have to calculate so much stuff. Yes?
So I noticed that the resulting recursion formula is
That's exactly what it is. Sure. Okay, but we haven't gotten the benefit of making a simpler calculation yet. That's what I'm talking about. So we can make a simpler calculation by figuring out what the heck is this. A to the n minus a to the n minus 1. I could factor an a to the n minus 1 out of it, and I get a minus 1. So that's one less exponent that I have to calculate. And if I happen to have a table of a to the n minus 1, that's already been calculated, I could use that. So this wasn't a great example for saving some calculation by doing this. So that's because the cheat method does not give me the most efficient way to get the new thing from the old thing. So now I should look at this formula and say, is there a better way to get from f of n minus 1 to f of n besides subtracting both sides? How can I calculate this one based on that one? Multiply it by a. So a better way is actually f of n is equal to f of n minus 1 times a. Now I've saved some calculations because I'm not doing any exponents, right? Because I'm just using a stored prior value and multiplying it by a, which is a lot less computation. You can't get that with the cheat method. You have to use real brain for that. Yes? You are allowed to do the cheat method, which is why I spend time going over it. Okay, so that was just an introduction of why we might want to have recurrences. The cheat method will not give you the one that gets you some benefit, but it will answer your questions on the tests that say find a recurrence given this formula. And on the homework, too. But you should actually spend some time trying to figure these out. Don't spend forever, but a few minutes per problem, and then if you get it, it'll be sort of like winning a little video game. It's kind of fun. Okay, so you have some problems like that on your homework. So some of your problems look like this, where you are given formulas like this. What's the difference between something like f of n and a sub n? Is there a difference? I want you to write down, what's the difference between something like f of n and a sub n? Is there a difference, and what is it? So what does a sub n mean? Write it down. But a basically equivalent question is, when would I use a sub n and when would I use f of n? Raise your hand if you have an answer that you agree on with your neighbor. Anybody know? Raise your hand if you think there is a difference between something like a sub n and f of n. Raise your hand. It's fine. Raise your hand if you think there's a difference. Okay? And raise your hand if you don't think there's a difference. So many of you aren't voting. Raise your hand if you don't know. Okay. Good. Thank you for voting. There isn't a difference. There is no difference. So they are just different ways of writing the same thing. However, they are usually used in different contexts. So remember that part of what we're doing in this class is learning some different languages. This is mathematician language. Mathematicians also use functions, but if they're going to actually use a whole bunch of these at the same time, they like to use subscripts because you get to write less things than putting parentheses all the time. That's literally the difference, is that they're using a subscript instead of parentheses and putting that same number in there. The reason why they're doing that is because they're going to do things like this. And that's a heck of a lot more of a pain than writing this. That's the main difference. The other difference is I'm usually going to use f of n if I'm going to calculate it once and I'm not going to put a bunch of them together. So that's really the only difference. There's not a difference. The reason why I ask you is because sometimes people look at it and they're like, I don't know what a sub n is. It just means there's a parameter. Yes? That is true. So that is a great answer of why they're different. So if you're talking about all of those subscripts are natural numbers or integers like we usually are in this class, there is no difference, but in calculus there would be. So I could not write this for real numbers that aren't whole numbers. So that's a great point. So that's the other thing. If my function is continuous, I have to use a function and not a series or sequence. Okay, so these are the kind of problems where you have to write a recurrence. Again, you can use the cheat method on those. It's totally fine. This problem is not as hard as it looks. Give a recursive definition of Pm of n, the product of the integer m and the non-negative integer n. There's nothing special about non-negative. What does it mean? It just means it's 0 or bigger, right? So how do you translate this into math? Delete that. It's an integer. Who cares? Everything we do is integers. Okay? Oh, it's recursive, so I can just go ahead and write this, and I got to have something like this, and then something, right? It's got to be recursive. So the thing I have to do to figure out what this is, I can't use the cheat method until I know what the original formula is. So what is the product of m and n? How do you write that? M times n. So hard. I don't know why, but every single semester, every single student's like, what? Okay, it's not that hard. This is Pm of n is equal to that. So if you're having problems on WebAssign, hopefully you got this, but you wrote mn, and you need to put the times in there, that's all. So now you can use the cheat method to get that. Yes? No, you can write them next to each other. It just happens to be that on WebAssign we have a times in that. Okay, so we're going to derive the closed form for a recursive sequence. What's the difference between S of n and F of n? Nothing. It's just different letters.